All right, so let's say another job. Let's say you're a microbiologist. You stare into a microscope all day long and you're taking measurements of things that are infinitesimally small. So you get numbers like this. Now, here's the idea. What we want to do, once again, to put this into scientific notation so it's less to write, is we want to change it so that we've got our factor number up front times 10 to the whatever power. So in this case, what we want to do is this. We want to see where we want to move the decimal to. Now, if I go back to this last page, the rule was that we want to put the decimal so that this number here is greater than or equal to 1 and less than 10. So if I look here, that means I want to put the decimal here. I want this to become 5. Not 0.5 because that would be less than 1, and not 50 because that's greater than 10, but 5. Okay, which means I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So what I get over here is 5 times 10 to the 9th. Now, one thing which you may have noted. Notice how on these problems, this one and this one, I was dealing with a really large number and I ended up with a fairly large number for an exponent, 10 to the 12th. Same thing here. Here I had a really large number and I ended up with a large exponent. Now this is different though. This is a really tiny number, and you may or may not have noticed, but I actually moved the decimal the opposite direction from the other two examples. And so the way we deal with that and we think about it is that, well, the only change we make is that since we're moving the decimal the opposite direction, we just make the exponent negative. Okay. Another way to think about this is to go back to something we've done earlier in the chapter. What we've basically done is we've taken out a whole bunch of 1/10ths because we're dealing, this is a tenth, this is 1/100th, this is 1/1000th. So because we're dealing with a really small number, we're taking out tenths instead of tens. And in this case, we took out 9 of them. Okay, but if you think about our rules for exponents and negative exponents, this would turn out to be the same as the reciprocal of 1/10 with a negative exponent, because negative exponents become their reciprocals like we have here. Okay, and so that's a little bit to think about, but really the way I like to remember it is that if you're dealing with a really small number, really tiny decimal, that means your exponent's going to be negative. If you're dealing with a really large number, like our very first example, it just means the exponent's going to be positive. Okay, so I think that's the better way for you to remember things. Really tiny numbers, negative exponent. Really large numbers, positive exponents. All right, so let's try another one that's a really tiny number. Now first, before I do it, think to yourself, where's the decimal supposed to go? Now, hopefully you said it goes here, between the 6 and the 1, because once again, the rule is to move the decimal so that that lead factor is somewhere greater than or equal to 1 or less than 10. So in this case, 6.1. Now, if I count up how many places I just moved the decimal, that's 1, 2, 3, 4, 5, 6, 7 places. So I'm going to do 6.1 times 10 to the 7th. Okay, but because this was a really tiny number and I had to move the decimal to the right, this is going to be -7. Once again, it's a really tiny number, which means I'm going to represent it with a negative exponent. Okay? All right. So now, let's take a look at these. Let's do a few other problems. Write the numbers below in scientific notation. So basically what we've come to is figure out where the decimal is supposed to go and figure out how many factors of 10 it took to get it there. So take a look at problem E here. Think to yourself, where does the decimal go? You want it somewhere between greater than or equal to 1 and less than 10. All right, hopefully you realized it went here. So the answer is 5.62 times, and I had to move the decimal 1, 2, 3, 4, 5, 6 places to the left. And the reason why I had to move it left was because it's a really tiny decimal. which means that this 6 is going to be negative. 5.62 times 10 to the negative 6th. All right, let's take a look at f. Okay, now once again, the decimal, it's invisible, but it's right there. Where should it be moved to? Well, in this case, it should be moved to here, 9.4. And I had to move it 1, 2, 3, 4, 5, 6 places, so 10 to the 6th. But in this case, it's a positive 6 because, again, it's a really large number. Large numbers imply positive exponents, and because it's large, I had to move the exponent to the left this time instead of to the right. All right, let's do this last one, g. The decimal should go here, make it 8.1, times 10 to the 1, 2, 3, 4, 5, negative 6th. Okay, because I moved it 6 places, but it's a really tiny number, which means it's a negative exponent. Okay, now, hopefully, as you practice this with the work you're going to do on this, that you're going to also be able to do the reverse, to understand it literally forwards and backwards. So let's take these 4 problems. We're going to write these scientific notation numbers in standard form, meaning write them back as a normal number. So it's just really the reverse process. Here I've got 6 times 10 to the 7th. Let's put our 6, and I'll put the decimal here temporarily. Now, 7 factors of 10. Now, what's important here is that it's a positive exponent, which means that originally this was a really large number. This represents a large number, which means I'd like to shift that decimal 7 places, and to make it larger, I'm going to go to the right. 4, 5, 6, 7. Okay, which means the original standard form number was 60 million. Okay, so take your number, figure out where the decimal is, and then shift the decimal according to this exponent with positive exponents representing really large numbers and negative exponents representing really small numbers. And that'll tell you which way to move the decimal. All right, let's take a look at this next one. 1.285 times 10 to the 4th. Now that 4 is a positive exponent, which means this was originally a large number. So I need to move the decimal so that it recreates that large number. So in this case, to the right. 1, 2, 3, 4. So not a huge number, but a large number, 12,850. Now, it's at this point I'd like you to make a mental note to yourself, and you might want to even put this down in your notes, that this number, the exponent, is about how many places you shift the decimal. Okay, do not ever, ever, ever equate this to how many zeros are in the problem. Because notice here, in this case, it was a single digit 6. We moved the decimal 7 places, and we filled those 7 places in with zeros. Okay, but on this one, it was 1.285, and then we moved the decimal 4 places, but 3 out of those 4 places were already taken up by the 285. So I only had to add 1 extra 0 in. Okay, and this is a common mistake people make. They think this exponent represents the number of zeros you add on, and it isn't. If this was the case, I'd have 4 zeros here and not 1 0. Okay, so realize that the exponent is all about the number of place values you move the decimal, not how many zeros. All right, let's wrap up. C, 9.9 times 10 to the negative 5th. Now that negative to us means that this originally was a really tiny number. So when I shift the decimal 5 places, I want to make it so that I'm recreating that tiny number. So in this case, it means I'm going to go to the left. So 1, 2, 3, 4, 5. Put the decimal back in. Fill in the gaps with zeros. So I get 0.000099. All right. All right, and one last one. 5.4. Oops, I should move that over a little bit. 5.4 times 10 to the negative 8th. So again, this is a really tiny number, so I have to shift the decimal accordingly. I'm going to go to the left. 1, 2, 3, 4, 5, 6, 7, 8. A little sloppy here. Fill it in with zeros. So I get 0.00000054. All right, so that's a little bit on scientific notation, both how to change a standard form number into scientific notation and how to change it back.